Welcome to CSP channel. How to learn easy way of physics. I am Chary, physics faculty. Today we are going to discuss about waves. What are the main important key points in this lesson? Wave. What is wave? Wave motion. Okay, waves on daily life basis. Next, types of waves. Types of waves and parameters of waves. Parameters of waves or characteristics of waves. We can say like that also. Here is the main key points are in the waves, which they are wave motion, wave on daily life basis, types of waves, and another one is parameters of waves. Now let us discuss about wave. What is wave? Wave. How to define it? So these are the points. Okay, we'll discuss about the wave. What is wave? Actually, what is wave? It is the disturbance. It is the disturbance. It is the disturbance that propagates. In space. The energy transporting from one place to another place. The energy transporting from one place to another. But the transporting the energy without matter, but transporting energy without matter. Without matter. See this? It is the disturbance that propagate in space, the energy transporting from one place to another, but transporting energy without matter. The matter is consists of number of particles. The particles are not moving, they are vibrating, they are not moving with energy. The energy is transporting through the vibrations of the particles here. So that's why the matter is consists of many particles. Here matter is not moving with the energy. Only the energy is traveling, energy is moving in the medium from one place to another places. Like this, we can define it. It is the disturbance that propagate in space, the energy transporting from one place to another, but transporting energy without matter is called wave. Right? You are getting my point? This is the one of the definition of wave. I am going to discuss wave motion. What is wave motion? Wave motion. Wave motion. It is continuous disturbance. Vibrations of particles. Vibration of particles. Continuous in the medium. with fixed frequency. Fixed frequency. With fixed frequency, that is called as wave motion. It vibrations of particles continuous in the medium with fixed frequency is called wave motion. It's very simple. Particles are vibrating continuously with the same frequency. That is called as a wave motion. So here is the fixed frequency. It is getting a refraction, first of all reflection property and refraction. Next, polarization like this. Okay, right? Now the wave motion, once again listen, it vibrates of particles, means particles are vibration continuously with fixed frequency is called as wave motion. It's getting reflections or refractions and polarizations. So these points are the very important. Note down these points. Okay, now we are going to discuss waves on daily life basis. We are seeing many waves in the daily lives. So waves on daily lives. Waves on daily life basis. What are the waves on daily life basis? In the daily lives, which type of waves are we are looking? So many waves are there, but some waves we are discussing here. So which they are? So we next one is, here is look here, sound waves, visible waves, so ripples of water waves, radio waves. Next, earthquakes, string waves, earthquake waves, string waves, like this, some example, and matter waves, so gravitational waves, so etc. Many are there. Simply, generally we are discussing about these, that is sound waves, visible waves, ripples of water waves, radio waves, earthquakes waves, string waves, matter waves, gravitational waves. These are some daily life waves. And write these points. Again, we'll discuss about the types of waves. We are going to discuss types of waves. Okay. Now we are going to discuss about types of waves. Types of waves. Mainly these waves, many waves are there. Total these waves are depends on, when they are classified, they are depends on medium, particles and energy propagation. So waves are classified. Waves are classified. Waves are classifies basis on characters, basis on medium and particles. And next one is energy propagation. Energy propagation. So all the waves, they depends on medium, particles, energy propagations. So all the waves are classified the basis on, or the characters of basis on medium, particles and energy propagations. But on the basis of medium, how many classifieds of the waves we are discussing here? So on the basis of medium, the waves are classified. The waves are classified on the basis of the medium. So how many types of waves are there here? So first one is mechanical waves. Mechanical waves. And the second one is non-mechanical waves. Non-mechanical waves. Here the waves are classified on the basis of characteristics, which are medium, particles and energy propagations. First of all, we'll take the medium. So by depending on the mediums, the waves are classified mechanical waves and non-mechanical waves. Okay, write these points or take a screenshot. Okay. We are discussing mechanical waves. Here, mechanical waves. Mechanical waves. What are the mechanical waves that we are discussing? Mechanical waves. Here is, it's very simple. The waves which require the medium. The type of waves are called mechanical waves. The waves produced by the mechanical force. The wave produced by mechanical force. Mechanical force. Mechanical force with elasticity. So mechanical waves, the wave produced by the mechanical force here, they are called mechanical waves. The waves produced by mechanical force, that is called as mechanical waves, or waves. The waves which require medium is called mechanical waves. We can say like this, it's very simple definition. Mechanical waves, the waves produced by mechanical force or the waves which require medium is called mechanical waves. The medium is required. Okay, so waves are traveling in the medium. The medium is required in the mechanical waves. For example, string, waves on string, and waves on spring, and waves on water surface. So here sound waves, and sound waves, it is like this. We can say like this. These are the examples of mechanical waves. So after that, next one is non-mechanical waves. Write these points. Now we are going to discuss about non-mechanical waves. Non-mechanical waves. Non-mechanical waves. The waves which do not require the medium, those type of waves are called non-mechanical waves. The waves which do not require medium is no need to take the mediums. Without medium also, okay, the wave energy propagates from one place to another places. Here now the waves do not require the medium. Do not require the medium. Those waves are called non-mechanical waves. The waves are called non-mechanical waves, like this. Here examples of non-mechanical waves. Example, electromagnetic waves. Electromagnetic waves. And here is very simple. Electromagnetic waves are nothing but heat radiations, or infrared radiations, like this, radiations. Okay, now radio waves, gamma rays, X-rays, like this it is. So mainly the electromagnetic waves. All of these belongs to electromagnetic waves. That's why I given the example electromagnetic waves for non-mechanical waves. So now write these points. Okay. These points are on the basis of waves are classified on the basis of medium we discussed, and we are going to discuss about on the basis of particles. On the basis of particles. On string waves, not sound waves here. Here, musical instruments. Musical instruments. Musical instruments like violin, guitar, membranes of tabla, dolak, etc. Like this, some musical instruments, they are getting vibrations. The type of vibrations are called transverse waves. So the examples of longitudinal waves, examples of longitudinal waves, sound waves, and next one is surface of water waves. So next parameter is wave number. Wave number or propagation constant. It is represented by K. The number of wavelengths. The number of wavelengths in the distance is 2 pi. Is called wave number or propagation constant. The number of wavelengths in the distance is 2 pi. That is called as wave number. Here, from here to here, this is y, this is x. From here is 2 pi. From here to the distance is 2 pi. So here wave number is represented by k is equals to 2 pi by lambda. Next, here units. What are the units of wave number? Unit radian per meter. Next, phase. What is phase? Phase is represented by pi. The position of A wave. The position of a wave with respect to its direction and time is called phase. So a wave path, a way of vibrations of particle, the position of vibrations of particles along the wave propagation, that is called as phase, or the position of a wave with respect to its direction and time is called phase. So from here to here, its phase is 90 degree. Here is 180 degree. Here is 270 degree. Here is 360 degree. Okay. For one complete cycle, the phase is taken as 360 degree in radians. Okay, how to mention in radians? Already degrees are mentioned. 0 and here is pi by 2 radians. Pi, here is 3 pi by 2 and 2 pi radians. These are in radians. Okay, write this. Now next parameter is wave function. Wave function is nothing but a displacement of the wave. It is a displacement. When the quantity oscillates, oscillates, then the displacement represented by. So here is for a sound waves. In the sound waves, vibrating the particles, they have pressure or density. Their fluctuations each other. For light waves, we'll take the light waves. In the light waves, the particles are vibrating, having electric field and as well as magnetic field. If we'll take the electric field or a magnetic field fluctuates each other in the wave propagation. So here is y depends, the displacement of that particles, or the displacement of where is that quantity depends on x and t. X and t. This is a wave. The wave propagates. Y here x. X is the distance. Y is the displacement. Okay, the speed of the wave like this. Okay, here is the distance is mentioned from here, distance, and again from here to there, but here is mentioned the distance. The speed of the wave is capital V. So displacement on y-axis, distance is on x-axis, where the particle getting vibrations. Here maximum vibration, here are the minimum vibrations. It is traveling along the direction in the medium, along the positive x-axis. Hence, the function of wave traveling can be represented yx comma t, y of x comma t, that is equals to f of x minus vt. Y of x comma t is equals to function of x minus vt. If we will take the pulse, Suppose if pulse is at time t is equals to 0, we are taking one of the pulse here. This is one of the pulse. Is ready to move along the positive x direction. Now here is y. So the particle is it is getting vibrations along the wave p. It is a particle. So the distance is x naught. Distance is x naught. At a time t seconds, the position of wave pulse like this. From here to here, distance of the particle, where the particle is indicated along the path of the wave pulse, displacement, and it is distance. The speed of the wave pulse is v. In the time taken t, the distance travelled wave along the positive x direction. It reaches vt from the y-axis. So all the measurements we should take from the origin. Hence the wave function, y of x comma t is equals to f of x minus vt. Here x plus vt. Y of x comma t is equals to f of x plus vt. The wave moves in negative x direction. This is represents wave moves negative x direction. At the time t is equals to 0, the wave function can be represented y of x comma t f of x minus vt. This wave function is represents when the wave pulse moves in positive x direction. Wave is moving in positive x direction.